Hello everyone. This video we are gonna go over Matplotlib module. It's a very useful visualization module in Python that we're gonna get to learn. Before we start, Matplotlib simply stands for MATLAB plot or plotting library. And if you have worked with the software, the commercial software Matlab ever, and you have used with the plotting in that software, you will see a lot of resemblance to Matplotlib. Basically, the foundational ideas of the way the codes are running here comes from the visualizations paradigms in MATLAB software. So let's get started. So like any other module, the first thing we do, we import the module. So the way you want to import it, the part of it that we're going to use more is matplotlib.pyplot, and we import it as plt. Again, this is one of other common way of importing a module. So plt is for matplotlib, np is for numpy, pd is for pandas. We are also using importing datetime. As you remember, we use this to find the date, find the weekday for our air quality data that we will also use in this video. So let's go ahead and import these modules, and now let's use our numpy to create some data. So now we have a line or numbers from 0 all the way to 3. So if I go ahead and say plt dot plot, basically just a plot, it's going to put x and x against one another, put x in the x-axis and again x in the y-axis, and it's going to show us a line. So one thing you want to pay attention here to, I haven't really called out to show the plot. This basically creates the plot. But Jupyter Notebook goes ahead and prints it, since this is the last line of code. But a good way actually to go about this would be to say pl2.show. And if you do that, you're going to get rid of this extra part of the plot that sort of like is the object or what it is that is being shown here. So now I run this. Now I have just a plot. I could be doing different things with this plot to see that it's actually an xy axis. So I could like show the x power to 2 as the y axis and see that effect here, or like the cube of x, and see that also here. One thing I could be doing is to put all of these plots together. The way you go about this is to create them in the same chunk of code, one after the other. And once you do that, the matplotlib basically encode that as you want them in the same plot. So if I run all of this, now all of them are at different one of them. So now I have gone ahead, also given them a name. So linear, quadratic, and cubic. So I also could be able to change the title, the x-axis title and y-axis title, y-axis and x-axis title. I could use that plt.x label, plt.y label, and also I could be getting the legend to tell me what are each of these lines. So as I'm giving them name, linear, quadratic, and cubic, the same thing here. Now if I say legend, it's going to show them. So let's go ahead and run this one time without the legend. So I can see that the title has, it's here, x-axis is here, y-axis is here, but still doesn't have a legend. But if I go ahead and also add legend here, now the legend is also added to the visualization. a very important concept, I mean, if you read this part, if you stop the video and read this, is basically the concept of current visual or current figure. Every time you work on with Matplotlib, basically you have a current figure, and if you call out X label, Y label, title, and legend, it's going to affect or change that current label. We'll see examples of that in a minute. So another example here. Now I want to this time use visualization to solve x in this equation. 3x power to 2 minus 2x power 3x power to 5 minus 2x power to 2 plus 100 is equal to 0. So now I want to solve this. As you remember, we did that once with just like with eyeballing and the results, scoring down. But here we can like use the power of visualizations to do that for us. So now we have an x and y, and we plot x and y. And this is our what we get. And we want to see where does this equation basically cuts the line 0. So to create that, we're going to create another line to sort of like see that where that cutting happens. So that's y2, and that's the second plot. So now that I run these two, now I can see that somewhere between -10, probably -5, and that that crossing happens. So I change that to -5 and 5 and see if things improves here. So yes, we now have like better resolution. It's somewhere between -3 and -2. So I'm going to go change that -3 to -2 and see that the answer happens around -2.6, which is an estimate for this this equation. Let's look at another example with the air quality data. So from the air quality data, we want to create the line plot for the first 30 days of year 2017, that the air quality data that we've been working on. So only the first 30 days. So all of the January, air quality measurement, we want to have one line for each day for the NO measurements. So before we get to solving this, we need to do some data cleaning that we've already seen in the second module Panda. So we clean that data. So we're just gonna like clean it here one more time and just start using the data. So this is the cleaning part, and now I create a loop since I want to like have 30 lines. I create a loop and I say basically the day from 1 to 30, like all of the days in January for the month 1, which is January for the year 2017, and only a species NO. So I create that Boolean mask and only capture those data, and then I assign my y to only from the value of those filtered out data, and then I also call my x from 0 to how many numbers that have. So that's the range. So for every one of these iterations, I will create a plot, and then I give the x label, y label, and the title to see the plot that's going to be shown. So now I managed to create 30 very quickly 30 line plots for each day. So now I can see that around this time of the day, which are in the morning from like perhaps around like 9 a.m., 10 a.m., 11, 12, there is that spike of air pollution. One of the things that we could do, we could change the figure size to make this bigger so we can see the trends better. The way you go about that, you just add this line of code, plt.figure size, fixed size. You basically assign the figure size that you are interested to have. So I'm using 15 and 7 as measures to get a bigger figure size. So now I have much bigger figure size, and I could be changing these to have rather smaller or bigger figure size. So now I have a little bit less big. You could also be showing image. So basically, to show an image, you need to import the image part of the Matplotlib library. We call that mpimg, and then we say read that image. So imread, which is basically an image that is in the same folder as this Jupyter Notebook file. That's why you can read it. So once I run this, it reads it. If I print the img, it's going to print a lot of numbers that are basically 0 and 1, the pixelated colors of all of those parts of the image. So all of these are showing the pixel of the color of white. But we are not interested in those numbers. What we are interested is to be able to see the image. So basically, if you say plt.im showed and then you say image img, now you can see the image. So I was actually interested for us to see this image, and this was also a sort of a side note for you to see. You can actually bring an image to Python by using Matplotlib. So here you can see sort of the language that you can use to change different aspects of the visuals that come out of the Matplotlib. So we already know the name legend. So this is a legend. This is a title. Major tick, minor tick. We know this is a line. We know this is a grid. The X label. We know these are called markers. These are spines, Y label, axes, minor tick labels, and so on and so forth. So at any point, if you wanted to change some part of your visual, if you refer to this image that I will be sharing, you will be able to Google, sort of try out codes and see if those things are gonna work for you. So for example, we could, that there is this thing legend. We could be trying to add a legend to our previous visualization. So we had this visualization, but our visual didn't have a legend. So let's go ahead and add that legend. So the only thing that is changing from the previous visual that we went over is the fact that now it has a legend, and it also has a larger size. So once I run this, now all of these legends are already also added to the figure. But you can see that it's kind of awkward where they are. So, and of course, this is a programming language. We should be able to control this as well. And the way you go about that, you could control the legend by changing two properties. The first property is where you want your legend be located. So you can put 0, sort of the algorithms smartly find where it's best to put, or you can specify where based on these numbers. And you can also say how many columns you want these values to be shown. So I'm specifying number of column 3, so I want only 3 columns of legend names, and then also the location 0, which basically puts it at the best possible spot. So once we run this, now we have 3 columns, and based on these 3 columns, all of the legends are added here. So I could be changing this to 5. then I would have 5 columns, and so on and so forth. I could be changing the location from 0. I could be saying I want it to be on, for example, upper center. So upper center, I have to put 9. So once I put 9, I will see that this legend will move to the center. But I kind of liked it better back there, so I'm just gonna put it back. Yeah, so this is how it would work. To practice this, change these values a couple of times and sort of like imagine what you would see and run it and see if you were correct or not. So this is a good practice to stop the video and run a few of these for yourself. And after that, you can bring your attention to this challenge. Before we get to the challenge, I have written a code to add a weekday to every row of the air quality data. If you go back to the air quality data, it doesn't have a weekday, and by weekday I means is this data for Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So like I want to know what day of the day each row is, and based on this date, I should be able to look at the calendar and know what time of the day it is. And this is a programming language, so hopefully there are ways to actually do this with coding. And there are ways. The way you go about this is basically by the module date time that I have already imported. But let me go ahead and import it as well here, so you know what that is, where that is coming from. So this is just the module that I'm importing. And I've created a function weekday retrieve, and this module, if you say datetime.date, and you give the year, month, and the day based on as integers, this will create an object of the date, and this object of the date has a function called weekday, which spit out the weekday for that specific date, and I'm returning that here. And once I create this function, now applying that function using the apply functions of data frame to all of the rows, and I get that weekday. So if I run this part of the code, I will have all of the date weekdays for each of the rows. So now I have to add this to my data frame. But before doing that, I switch from number 0 to 6, which stands for Sunday, Monday, Tuesday, Wednesday, Thursday, and Friday and Saturday, and I change them to actually the day representing them. So I go about that replacement that we've already done once before, and then I change that into a data frame, and then I call it a weekday, the columns, and then I join that with the data frame that I already had. And once I run this, now my data frame has a new column, weekday. So now I can go ahead and introduce you to this challenge. So this challenge wants you to draw the NO line plots of all of the Mondays. I'm only interested in looking at all of the Mondays of 2017. And to go about this, you probably already know to take advantage of Boolean masking. So give this a try. Stop this video, give this a try, and see how you can do this before I continue to watch, as I will be giving some guidance on how to go about this. So the best way to go about this is actually, filtering out your whole data and based on the Monday, and if they only keep the part of the data that you only need. So once you do that, your only data is gonna be for only the Mondays, and then based on all of the dates that you have that you can also capture with a line of code, all of the unique dates that you have, then you go through a loop through all of them, and based on the Boolean mask and the day, you can find your X, Y, and X that should be shown on these visuals, and then you plot them, and then you change the title, X label, and Y label, and this is what you will get. If you haven't already done so, stop this video before I show you the solution. Try this for yourself before continuing. So, the Boolean mask is simple to create. You just create based on the each Monday, and then you use the unique function to get all of the dates, and you go through all of the dates, and based on the day and the species, which were NO, that were specified by the question, and now you get the Y, which are all of the values of the NO values, and then you sort of create an X, which is from 0, 1, 2, 3, 4, all the way to 24, because every day has 24 measurements. And then you just plot it, and then you give names and titles and everything, things like that. Once you run this, you get the answer.